So when you were asked on the first page of your notes, as we look at examining prior patterns, you just gave me what you thought was happening. And now as we filled this in, we noticed that we were dividing by 2 each time. So they asked us what are a couple of our patterns that we could notice. This is what I would like for you to write down. The numbers are dividing by the base number as you go down. And if you think about what that base number was, our base number was that we were dividing by 2. And the other thing, if you take a look at that whole list, is that the positive and negative exponents are reciprocal. So make sure you have both of these written down as 2 important patterns. So if I look at 16, which is 2 to the 4th and 2 to the negative 4th, the most common mistake that students think when they ask them before what happens with negative exponents, they think it's a negative number. Okay? So if you told me the pattern was, I think if it's negative exponents, it's negative numbers, that is not the case. I want you to take a look. 2 to the negative 3, when you think of 1/8, what we are going to be doing is we're going to be talking about taking the reciprocal of that in this unit, which is 1/2 to the 3rd. Well, 2 to the 3rd is 8, so this is our 1/8. Okay? So I'm going to give you a minute. I know there's a couple of you that are still writing this down, and then we're going to take a look. So it says a power with a negative exponent means reciprocal of the base. Please make sure you circle or star this. Negative exponent means reciprocal of our base. So it says when multiplying, so when we are multiplying it for the times itself, the number of times you multiply is the absolute value of its exponent. For example, 4 to the negative 3 means take the reciprocal. And so one of my hints is I'm going to ask you to just write it as 4/1, because then a lot of you see it as a reciprocal much easier. So 4/1, the reciprocal is 1/4. I'm going to write that out how many times? 3 times 1/4 times 1/4 times 1/4. Well, 1 times 1 times 1 is still 1, and 4 to the 3rd. At this point, you can leave it like this, but you will be able to use your calculators. And if you put it in your calculator, 4 to the 3rd means 4 times these 3 4s, so this is going to be 16, and 16 times 4 does give us, I would also take this answer. But a lot of times I'm going to look at you using the rule and just stopping it at that point. So as we are taking a look at the problems down here, first thing I'm going to do is I'm going to put the 2/1. I'm going to show my work down below, and then I'm going to put the answer in here. So if I think of this whole thing to the negative 2, I'm going to rewrite it as the reciprocal of 2, which is 1/2. So we're always looking at reciprocal. The reciprocal of 2 is 1/2, and now this becomes a positive 2. So it was negative, we're going to make it positive. So please write that. So as we are taking a look at this, this now means we are going to take 1 to the 2nd divided by 2 to the 2nd, which will leave us with 1/4. As we are taking a look at the next one, we're going to put it over 1. So if I'm going to start to rewrite this, as I do that, Josh, I'm going to start with putting 1/3 to what power?
4.
To the 4th now. So the negative becomes positive because we are taking reciprocal. So it's now positive, okay? And we've done the reciprocal of this part. And so if I am looking at that, my answer is 1 to the 4th, which is simply going to be 1/3 to the 4th. 3 to the 4th is 3 times 3. 3 times 3 is 9. And 9 times 9 is 81, right? So it's having 3 or 4 3s, right? 9 times 9. And you could put this in your calculator. So on your calculator, you should have this either caret button, 3 to the 4. Some of you might have a y to the x key, or it might be x to the y. And if you put that in, you should get 81, okay? So let's take a look at this next one. We have m to the negative 6 over 1. So if we are taking a look at this, Tyler, we're going to do the reciprocal. So m over 1, its reciprocal would be 1 over m. This whole thing is now to the 6th power, which means I'm going to take 1 to the 6th and the m to the 6th. We love 1 to the 6th. Cameron, 1 to the 6th is 1 to any power. Multiply how many 1's together? 6. What would you get? So if I have 6 1s and I multiply them all together, what do I get? 1. And so I think anytime I have 1 to a power, that's nice, because it's always going to give me 1, right? So 1 to the 6th is not 6. We're not taking 6 times 1. It means I have 6 1s being multiplied. That's going to be 1. And in my denominator, I'm going to have m to the 6. Okay. When I look at 1/7 to the negative 2, I'm going to take the reciprocal of 1/7. The reciprocal of 1/7 is 7 over 1 squared. Or we can just write it as 7 squared. 7 squared, at the beginning of the year when you multiply or memorize, 49. Okay? So when you're thinking about those. So we have 2 other pages in your notes to take a look at before we do your test reflection and take a look at those. Questions on any of these? Negative means what? Negative exponent means what word? Reciprocal. Negative exponent means what? Reciprocal is always going to be our negative exponent. Negative exponent, reciprocal, right? When we looked at this table, I don't know what your prediction at the beginning was, but anything to the 0 power, if you remember, we read that as one of our, when we did, these are our, as we looked at our ELOs, and so we were looking at, okay, exponents in scientific, and we read one of them the other day, and it said anything to the 0 power is always equal to 1. Anything to the 0 is 1. And that is one of the properties that we want to take a look at here. It says any non-zero number or variable to the power of 0 equals 1. The only number that doesn't work for is 0. Why can't you use 0 as a base? Since the first property on the previous page would have given us 3 to the 0 equals 1, 2 to the 0, 1 to the 0. And if we looked at that, this means 0, which is when you multiply 0 times 0, you get 0 equals 1. But also if you consider 0 to the 3, all of these equal 0. So it can't be 2 things, right? So it can't be both 0 and 1. This is impossible. So we say that it doesn't work for 0. Okay, so it says, always you will see in the definition in mathematics, any non-zero number. So, anything to 0 power equals what?
1.
Anything to the 0 equals 1. So the first one, 5 to the 0 equals
1.
G to the 0 equals
1.
negative 3x to the 0.
1.
This whole ugliness of 3 plus to the 0 power equals 1. This is the only one that's a little trickier.
Negative.
This is like negative 1 times 4 to the 0. So the 4 to the 0 is still going to be equal to 1. But this negative out in front means negative 1 times 1. So this is the only one that's negative. So just be careful. The question comes up, well, how come this one isn't negative? It's in the parentheses. Okay? So that parenthesis, we talked about it on Friday. It means a lot if you're inside the parenthesis or outside as you look at those. So just be careful. Okay? So simplifying our exponents. So now we're going to kind of combine these 2 things. So simplifying exponents means that all powers must be evaluated in your answer. And you can't have more of that same base. And usually you can't have any negative exponents. So I'm going to start with this one being over 1. As I am taking a look at that, as I look at that, Ivy, what are we gonna write down first? So I have negative 4 over 1 to the negative 2.
Oh, like, you make it a reciprocal, right?
We're gonna do reciprocal, so this is gonna give us reciprocal, so the reciprocal of negative 4 over 1 would be what?
Negative, or 1 over 4.
1 over, we'll keep the negative. I don't care if you wanna keep the negative with the 4 or with the 1, okay? And then Maddox, instead of negative 2, because we've done the reciprocal, this now is gonna become a positive 2. I'm gonna take, if I'm thinking about this, 1 to the second, and down here, I'm gonna keep my parenthesis and go negative 4 to the second. Okay? So Brad, if I'm taking a look at it, 1 to the second, we love 1 to a power, equals 1. And in my denominator, Kira, I'm gonna have negative 4 to the second, which equals, okay, we're gonna be taking, what does negative 4 squared mean? That means negative 4 times what? 2 or times negative 4? Times negative 4. So negative times a negative would give us positive how much? 16. Okay? So it's really easy to go with negative 8. That's a common mistake that's made. Or even go with 8. It's not 4 times 2, so just be careful for that. All right, so we're taking a look at that next one. And Jaden, I have 6 to the negative 2 power. Help me out. What am I going to do with that? Okay, tell me what to write as a reciprocal.
1 over 6.
Okay, to what power?
Second.
To the second. And Kaizen, 5 to the 0 is what we're multiplying at times. Anything to the 0 equals 1. So it's going to be times 1, right? So now I'm going to take in my numerator. So Jonathan, I have 1 squared over 6 squared. 1 squared is going to leave us with 1. And in my denominator, Autumn, 6 squared equals 36. Taking a look at the next one, 3 to the 0. Morgan, what do I know 3 to the 0 is equal to? 1. And it's times 3 to the second. So if I'm multiplying those, I just get 1 times 3 to the second. That's just 3 to the second. Live equals? Careful.
9.
Yeah. And if it helps you, write out the expanded form. This is never going to be wrong. If you're doing this on a quiz or a test and you're like, oh, I'm stuck, I can't figure this out, obviously you can probably use your calculator, but if not, think about what it means, and you should have 9 for that. So the bottom part, if we read that direction, it says, okay, so if we are simplifying algebraic expressions, that means you can only have positive numbers as exponents, no 0, and no negative. And I put that right on the top of the quiz, and I'm still amazed that people will rewrite that and not keep it in this form. So as I am taking a look at this, Ambry, how would I first rewrite?
1 over y.
1 over y. And Kale, if I'm looking at it, instead of negative 3, it's now going to become positive 3. And if I'm looking at that, that means I have 1 to the third, which is just 1. And I'm going to have in my denominator y to the third, which is simply y to the third. Just found the reciprocal of it, right? I'm looking at this next one. As I'm looking at this next one, are you ready if we start off? Go ahead, Alexander. K to the 0 equals 1. But now, as I am looking, Grady, I have k to the negative 2. Mm-hmm.
1 over k.
Okay.
2 is positive.
Positive 2. So I have 1 times that. So 1 times anything is just going to be what I start with. So I can just go 1 squared over k squared. And my answer, if I'm finishing this one, should it be what, Amy? 1 over k squared. As I'm taking a look at that question. Okay. Questions as you. So on the bottom of page 7, I would like you to write negative exponent And the word we want to always associate with our negative exponent is what word? Reciprocal. Negative exponent reciprocal. Negative exponent reciprocal. When we're thinking about a zero power, x to the 0, it is always going to equal 1. Anything to the 0 always equals 1. So, the answers are correct in tonight's workbook in the back, although they weren't on G1. Okay? So, I want to take a look and kind of start the assignment with you. So, if you would please, as we simplify, as you look at page 39, simplify means no negative and no zeros. So, I ought to start with 3 to the negative 2. How am I going to rewrite that? 1 over 3 to the positive 2, right? So Jared, if I'm taking a look at that, the 1 squared, right? That means, right? 1 squared over 3 squared, my answer would be
1, 9.
1, 9. So because you might have a little work, circle your answers as you're doing these, right? Okay. As you look through the rest of this, someone said, oh, like, we haven't had fractional ones, but we have the 1/7. But what do you do with 3 over 2 if it's to the negative 2 power? The reciprocal. It's still going to be to the second. It's just that now you're going to go 2 over 3, and you're going to take each of those to the second power to get your answer. Okay. So you have these questions. We're going to take a look at your